message brokers and architecture of RabbitMQ. Then we will have a code walkthrough, and there is a demo. Now, so if we understand messaging queues in layman terms, it is nothing but, let's say you have to deliver your post.
Yes.
Okay. Am I audible?
So you can use this one. You can use this one.
Okay. So if we discuss about messaging queues in layman term, let's say you have to post something and you goes to the courier service, okay, and you post your messages over there or email, and then it will go directly. And then you don't need to worry what will happen after it. The post office will ensure that the message goes where it is intended to. So in this analogy, we can think of the one who are trying to send a message. It will be a producer. This post office will become a message broker, and the recipients will be our consumers. And you could see, so message queue act as a buffer between your producer and your consumer. Then once a message inserts into the message queues, then it will be processed by consumers, and then they will basically pull the messages from the message queue, and then it will further process. Now it does asynchronous communication because you can, all these three services, producer, consumer, and your message broker, you can run them in the separate machines. So in this way, your resource utilizations gets better. Now, this message broker and messaging queues are interchangeable terms that are being used, and message brokers act as a centralized hub between your producer and your consumer. And here you can see that as a consumer, you could add another message broker also. And there could be multiple independent services that are trying to send a message to your message broker. And in RabbitMQ, there is a different architecture because in all other queues like Kafka and all, we have a topic, but in this, there is this exchange and then the queue. That will, I will explain it further. And then you have routing. Routing means to which server, to which consumer you want to send a particular message. So this is done through routing. You need to define some routing rules. In message, there is a metadata. So you define your routing key and building key that will take your message to the intended consumer. Then there is this transformation. So let's say your publisher is written in some other language. Let's say it's written in Go, and your consumer might be written in some other language. It's in Python. So there you can build your RabbitMQ architecture like this. And a message could be an example of an order that being consumed by a payment service. So this is a message broker. Now, if we look about messaging queue, why we need messaging queues? Because earlier it was monolithic architecture, right? So everything was tightly coupled, and there's no dependencies and bottlenecks involved. There were too much bottlenecks involved at that time, but through messaging queues, we will see how it overcome this problem. So now you can see in traditional approach, let's say these three services, these are three independent services, and let's say if some alert comes, it has to send an email. It will call this email service. If let's say someone makes a payment, it will also send an email. Then even once a user registered, and it has to send an email. So these three services are independent services, and they are trying to send email. Now, if let's say there is a peak load, so many users comes at a time, and then they are trying to access email service. In this case, what will happen? That email service will block. It will not be able to work properly. Now, with messaging queues, if we add a messaging queues in between, then whatever messages, whatever services, all three services are trying to send, they all will be in the queue. This messaging queues work in a FIFO approach that we have already studied in our data structure. So what first in, first out. So let's say all these services are trying to send a message to email service, so they all first goes into the queue, and then the email service will take these messages one by one. And let's say you have at peak load time, you can also increase the consumer counts. As sir already mentioned, you can also increase the consumer count. That means email service can be increased multiply, so that the messages and all these services can be consumed. So this is the advantages of messaging queues. So there is decoupling, that's a producer and consumer operate independently, and it enhances your scalability. Now they do asynchronous communication, as I already told you that you can utilize your resources. And with message persistence, let's say you are sending a message and it is being consumed by your consumer. At that time, it will send an acknowledgement that yes, I have received that message, and then you can process further. Now it also does load balancing for you. That means it is distributed messages across multiple consumers for better handling peak loads. So whatever peak loads comes, you can increase your consumer counts. So these are few use cases where messaging queues are being used. In microservices architecture, you use messaging queues. In data streaming services, like let's say OTT services, where first you have to upload a video, then in the background the video gets encoded, and all these services you can make it as a message as different services, and in between you can apply your messaging queues, so that once a person is trying to upload a video, then if let's say so many persons are trying to upload a video, then the encoded service will not get affected by it. And then in this event-driven architecture also, you can use messaging queues. Now there are a few types of message brokers available. We have RabbitMQ, we have Apache Kafka. Apache Kafka is the most famous after RabbitMQ. Then you have ActiveMQ, IBMQ, and then Amazon SQS. You have already seen our demo of it by Windows. So let's discuss about RabbitMQ. So RabbitMQ is an open source message broker. It is written in Erlang, and it supports multiple protocol, that is AMQP, STROM, and MQTT. It was first built in AMQP, and this STROM and MQTT comes after. It was done by open source people, and it supports multiple client languages, let's say Java, Python, Ruby, and all. This is the architecture of RabbitMQ. So here, as I have already told you, it first your message goes in the exchange, then exchange sent to a different queue. First, you have a direct exchange. In this direct exchange, what happens? Whatever building queue you have defined, it will go directly to that queue. Now, in topic exchange, what happens? You need to define some routing pattern. Based on those patterns, if they matches with your queue, the message you will send goes to those particular queues. Then you have fan out exchange. In fan out exchange, what happens? Whatever queues that are available, it will send the message to all these queues. And there is two more types of exchanges. There is header exchange and default exchange. So in the demo, I have used default one. So here you have producer, and then you have consumer. This is the broker, and then these arrows are called channels. Now, features of RabbitMQ are that it is cross-language. You can write your producer in different language and consume with a different language. It is very secure, and then it does your message acknowledgement. You can define certain message acknowledgement rule in your messages. Then you have a good management console. There is a browser console also. Then there is extensively CLI support for you. Then it is RabbitMQ is cloud friendly. You can have Docker image instances, and then you can apply use with Kubernetes and all. Then you have plugin builds in. These plugin builds by open source community. Now we will have a code walkthrough of how a producer and a consumer works. So this is the code of producer. Here you can see this is a Pika library that we are using, and this will help us connect with our RabbitMQ server. Now RabbitMQ server is currently, I have set up, it is already running. You first need to deploy your RabbitMQ server in your machine. So here this line number 5 is trying to connect with your RabbitMQ server. my server was running in my local machine, so where I have defined localhost. You need to define IP addresses if it is running in some remote machines. Then you have to create a channel that I showed you. After creating a channel, if you try to send a message directly, it will drop. So for that, you need to build a queue. You need to define this queue declare. This queue declare function is idempotent. That means whatever queue you are trying to create, it will create only once. So here we have mentioned the name of the queue as welcome. Then we are trying to publish messages. Now here in Exchange, I have kept it as empty. So this is a default queue, default Exchange. Now we have defined the routing key. We would in the routing key we need to define the name of the queue, and then in the body whatever message we want to send. Then after that we need to close the connection. Okay. And this is the consumer code. The connection part is all same, but you could see that we have again defined a queue here. Now you would ask why you have done defined the queue again, because let's say a consumer doesn't run in once you start a your producer. So let's say if there is no queue available, then from where the consumer will try to fetch the data. So that is why we have to define the queue in both our consumer or producer, because this message queue, this queue declare function, I have already told you it is idempotent. So and then there is this callback function also. So this callback function does your business logic. Whatever business logic you want to write, you have to write in this callback function. Then we will try to consume. We name the queue name, and then we have done auto acknowledgement to true. And then once the message arrives, what action we want to have, we have to define a function. Then we will start consuming. So this is how it works. So until now, anyone have any questions? Okay. Then there is this video, demo video. I have not prepared a live demo. So there is video after it. I will have to go and play the video. Okay, here you can see that first we are trying to run the consumer service. So this we have started our consumer service. Now in this we will start our producer service. So as you can see, as we have started our producer, the consumer is trying to consume the messages. So yes, so this was the live demo, and it was not live. Sorry, it was just a recorded video. And then this is the code gist. If anyone wants to have this code, they can have it and scan and download the code. Okay, I think that's a quite fast-paced demo. Okay. So yeah, thank you. You have been an amazing audience. That's it. If you have any questions, you can ask.
I have one question. So in case of topic exchange, the routing key mentioned is the queue name. So
Yes.
eu.du, that pattern. So the pattern, there are two queues to the topic exchange.
Yes.
Q2 and Q3, and the routing pattern mentioned is eu.du, maybe the country names, I guess, and US. So these are the queue names that the pattern will match to.
Correct.
Okay.
These routing key are a part of message, that you have to fit. So it is a metadata, and then in the queue also you have to have this key, binding key. Then only it will match. If the pattern is matching, then
So
this
it is an
particular message.
argument of the queue that this is the routing pattern,
Correct.
or is it the queue name?
No, it is not the name.
It is not
the name. It is the binding
argument
key.
from the.
There is one more argument you need to mention, the binding key.
Okay. Fine, thank you.
Okay, thank you.
Can you share that slide of code, please?
Yeah. So here you can download the code base. Basically, this was my second talk, so if any feedback, that would be. Okay, thank you.
Okay, thank you for that insightful one. So, a round of applause for him, please. And now we will have a break for 10 minutes, just a coffee break. So the rule is, there will be a notepad over there and a pen. Write feedback, take your coffee, have your seat. That's how it will play. And हाँ, हमारे बंदे observe कर रहे हैं लोग. Question पूछोगे, notes लिखोगे, कुछ अलग करोगे तो शायद कुछ मिले. तो just बता दिया. Disperse for coffee.
And when you write it, write your feedback on the notepad, you can give it to me, okay? Or any of the volunteer. वही मत छोड़ देना. Okay. So you can grab your coffee and the biscuit. आजा भाई. भाई देखना बिना फीडबैक